So we talked about the basics of factoring in class. The problem is with factoring is even if we have our problem set up the correct way, factoring is not always going to be a method that's going to work. For instance, the problem you see in front of you, if we're looking for multiples of 3, and we're looking for multiples that add up to be -5, well, that's really not going to work. We can't factor this. Does this mean there's no solutions? Absolutely not. For instance, if you look, I just pulled up the graph of this, we can clearly see that there are going to be solutions to this equation. There are definitely two x-intercepts, and we need a way to be able to find these. So there are definitely solutions to this equation. However, factoring is not going to be a method that's going to work. Is square rooting going to work? No, because there's more than one. If we can see there's more than one x term here. So our only method we have left at our disposal is going to be the quadratic formula. Our best choice is going to be the quadratic formula. So if you remember from previous experiences, quadratic formula is an ugly equation, but the pro to it is that it does work every time. So the quadratic formula says, if you have your equation in the form, and I'll write it up at the top, one side's equal to 0, and you have ax squared plus bx plus c. So a, b, and c, you can see it are just the numbers in front of x squared, x, and then the number by itself. It's that your answer x is equal to negative that b value plus or minus the square root of b squared minus 4ac. Notice all of that is under the square root, and then divided by 2 times a. So if we look at the equation we have here, you look at your coefficients, the a value is the number in front of x squared. If there's nothing there, it's going to be 1. So a is equal to 1, b is the number in front of x, which would be -5, and c is the number all by itself. It would be +3. So this is a plug and chug kind of operation here. We take our values, our b value, so it says negative your b value. X is equal to negative, and we plug in, anytime you plug in, remember it's a good idea to put things into parentheses. Negative your b value, plus or minus, and we'll get to that plus or minus portion in a second. Plug in -5 for b, squared minus 4, a is 1, c is 3, all divided by 2 times a. It's ugly, it's a lot of calculations, but it will result in an answer. So if we go through and simplify this, the place you want to focus first is the square root. Simplify this first, and it'll make your life much easier in the end. So if we take what's inside the square root here, so negative -5, I'm just going to write that as +5. Plus or minus, we look inside the square root, we have -5 squared, that's going to be 25. Minus 4 times 1 times 3 is going to be -12. And 2 times 1 is 2. Really stay with that square root until you get to a final answer with it. 5 plus or minus square root of 25 minus 12 is 13. The easiest way to simplify this equation with the fewest mistakes is definitely to simplify what's inside the square root first. Once you get down to our square root, if it's a perfect square, take the square root. If it's not, we want to try and simplify that square root. In this case, square root of 13, factors are 1 and 13. We can't simplify that square root, so this is actually an acceptable form for our final answer. The plus or minus just tells me that one time I'm going to be adding the square root of 13. Remember, I'm looking for two answers. And the other time, I'm going to be subtracting the square root of 13 to get my answer. If we're looking at decimal approximations, we'd say 5 plus the square root of 13 is about 8.61 divided by 2, so it's about 4.3, around 4.3. 5 minus the square root of 13 would be about 1.4 over 2, so the other answer would be about 0.7. So those were our approximations, but I would prefer your answer with the square roots, the simplified square roots. So let's look at one more here together for right now. So again, we're going to try and use the quadratic formula, letting you know ahead of time this one is not going to factor. Could you try and factor it? Yeah, I would suggest trying to factor any of them before you actually venture off into the quadratic formula. But this one's a little different than any one we've seen before because we don't have the basic starting point is, remember, you have to have your equation one side equal to 0. So I'm going to set this equation equal to 0 by subtracting 2x and subtracting 7 from the left, or sorry, from the right side and the left side. So my right side of my equation is going to be equal to 0, and then I'm left with 4x squared minus 2x minus 7. If I plug this into the quadratic formula, my A value is 4, my B value is -2, my C value is -7. This is going to give me my two answers. So we have our A, B, C values. Let's plug it into the quadratic formula. So x is equal to negative the B value plus or minus the square root of B squared minus 4 times A times C. All of that is divided by 2 times A. We simplify this. Remember, we want to focus on that square root first. Negative 2 is positive 2. We're simplifying that square root. Negative 2 squared. Make sure you're really careful and just think through this. We're saying negative 2 is being squared, so negative 2 times negative 2. It's always going to be a positive number, whether the number for B was positive or negative. So it'll be 4, and then I have 4 times 7 gives me a negative and a negative gives me a positive 112, all divided by 2a. Again, simplifying inside that square root, 2 plus or minus square root of 116 over 8. Now comes the point where we want to try and simplify that square root. So 116 factors would be 2 and 58, 2 and 29, and 29 can't be broken down anymore. So if we simplify the square root, it's 2 plus or minus still, and the square root simplified would be 2 root 29 over 8. This looks very similar as far as simplification goes from this step to the simplifying we did with the complex numbers. If you remember, if you had something like 4 minus 6i over 8, you said, okay, all of these numbers, all of these can be divided by 2. We want to do the exact same thing here. We want to look and see, can these numbers I'm boxing in, can these numbers all, do they have a common factor? Can they all be divided by the same thing? Absolutely. So they all can be divided by 2. This does not apply to the number that's inside the square root, just the numbers that are not. So if we divide all of those, it's 1, 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1 root 29 over 8. This is the exact answer. This would be a completely acceptable answer. If you wanted approximations, you'd take 1 plus the square root of 29, divide that answer by 8, and you'd take 1 minus the square root of 29 and divide that answer by 8 to get your approximations, which those would be about 0.8 if you type that into your calculator, and about negative 0.5. Really close to those numbers. So solving by the quadratic formula, kind of your wrap up here. The pro for solving with quadratic formula is that it works. It works for all quadratics. It doesn't matter if the best method might have been taking the square root or factoring. It's going to work for every single one of them. The con is it's a lot of calculations. It's a plug and chug method. It's a lot of calculations to do, but the good thing is it's going to work every time. So we will practice this and our other methods tomorrow and Wednesday in preparation for our quiz.